Hello everyone, Strikoder here and welcome to a new episode of the PT1 exam prep. So let's just get started. Today's episode is going to be about race conditions. So as always, let's start our machine in advance. So I'm gonna try to pass through these tasks, not in a deep manner, but let's just get started and check them out. So the introduction, they are explaining what is race condition probably. So let's say we are tasked with testing security of online shopping web application, and many questions pop up. So can we reuse a single $10 gift card to pay for a $100 item? So for instance, if you have, let's say, $10 Steam gift card or Amazon gift card, can you use that twice? So if you have two different computers or mobile phones and you try to apply them at the same time, would you get $20 or would you get $10 twice for separate accounts? So that's the question over here. So we have two types of race conditions, and these rooms introduce us to overall to general race conditions. Learning objectives, like to know what race conditions vulnerabilities and to use Burp Suite repeater. We're gonna check that together, and along the way we're gonna explain what threats and multi-threading means and state diagrams. So let's press complete and move on. Okay, next task. It's explaining a bit about multi-threading. So if you haven't studied already computer science, so it's a bit hard for you if you have no fundamentals of IT or at least of CPU, I would say. Any gamer would know what threading is, or programmer or software engineer. But if you don't know, it's just like the parallel processing of a process, which called multi-threading, and each process, while it's being processed by a thread. So here we have a program. As we can see, they are telling us that as if they are making coffee or baking coffee whatsoever, and they have here for us Flask code, written Flask, and in Python I mean, and here are the processes, and they are explaining to us that program is the executable code, memory is the temporary data which is being generated by the code execution and the variables and the data overall, and the state. So here is the important thing that we need to know about. So states, for instance, here in our photo, we have a new state, we have ready state, we have running state, we have waiting, we have terminated. So whenever a new process is being let's read here. A process usually hops between different steps after in the new state. Whenever a new process being initiated, it's going to the ready state. Whenever it's being called again, it goes to running, it finishes, then it's either it either goes to terminated or waiting to be running again or executed again. So that's the theoretical part, I would say. And here we have the Flask code. They are showing us that we can what's happening when we run without threading. And here they are telling us with an example. So I'm just trying to go past the theoretical part very quickly. If you need to have more deep information, you can read that by yourself. So here they are showing us the coffee machine, and we can see 3 coffees are being prepared. However, there are 2 cups waiting. Like you can say, I would argue they are waiting in the waiting state, but however, the waiting state should be we should be talking about the machines, not the cups. But here they are showing you that what's the process mean, what's multi-threading, what's program, and so on. Yada yada. And here they are showing us not unicorn, gonicorn, I mean, with 4 workers, and each worker has 2 threads and the ability of multi-threading. You downloaded an instruction booklet on how to make an origami crane. What should the instruction booklet resemble in computer terms? Program. What is the name of state where process is waiting? Waiting. Okay, race conditions. So here they are showing us that as if no, they are not talking about the workers. Here they are talking about reserved, as if 2 people try to reserve the same table probably. Yep, at the same time. And another customer is talking with another host and making a reservation for the same table. So in our case, we're taking this example. A bank account has 100 and 2 threads try to withdraw money at the same time. Thread 1 checks balance sees 100 and withdraws 45. Before thread 1 updates the balance, thread 2 also checks the balance incorrectly and sees 100 and withdraw 35. So whenever if you went to a bank or if you are in a third world country where you don't have card banks or credit cards or whatsoever, or if you are not old enough to have your own card, so here is your credit card bank. Like you have the IBAN. I don't believe other countries write the IBAN on the credit card, but in Germany they do. And you have the CVV on the other side, and so ever. Here is the number. So you try to pay, let's say that is the terminal. I know I don't draw that perfectly. So let's say we are trying to pay for or buying something. So let's say we have $50, not percent. And here we are buying with $40. So if we bought that $40, then we have, of course, $10 left. So before initiating any other payment, the bank should know if we have enough money at our bank account before buying anything else. Let's say at the other magazine, they have other terminal and we bought something that costs $30. So the bank account, the bank program would check and would see that there is not enough money to buy the other thing, the other item or the other product. So how this vulnerability might be? That was in our case day-to-day case scenario. So the vulnerability would be, let's say we bought $10 Steam gift card or Amazon or Leica or whatsoever. But the most popular thing would be Amazon, Steam, or maybe PayPal, I don't know, or Netflix. So I would stick to Steam and Amazon. And let's say with this gift card, there are 2 cases of race condition, either by trying to race the process on a different accounts, like here you have the first account, here the second account, and you try to apply the $10 at the same time on both accounts, which is not what we are talking about today. Or you have your account, let's say Strikoder, the name of the channel, and you try to apply the coupon or the discount code twice at the same time. So if there are no logic, or if the business logic is not that good, or if the code is not that, doesn't evaluate the, I would say, the gift card or the coupon code, so we would apply $20. But if there is enough validation, we would apply $10 and then get an error. And if we are trying to make a fraud or something, if we try that too many times, like with banks or whatsoever, then we might get nothing, because maybe even the $10 is a scam or whatsoever, or maybe generated by an AI, like the gift code, which probably that is gonna be not that often, or maybe never that happen. But as a programmer, you would think about all test cases. So either you get nothing, either you get the amount that you activated, or you get more. So we are interested about this case particularly. So how to get the $20? So by the logic of a program, it's not a binary case. So you entered the gift code or the coupon code or whatsoever, and you either get the money or not. It's not that easy. You have the first process, then you have the second one, then you have the third condition, and then you have, let's say, the final one, which gives the decision. Either the code is going to be activated or it's going to be not activated. So how this happens, when do we get $20 and when do we get $10? So let's say we applied the same request twice. So if you're not familiar with the term request, requests mean that we are sending a GET or a POST request. We would edit our requests with Burp, or you can curl that, and we're gonna send that to the endpoint or through an API. It really depends on the program, and try to check. We cannot check the backend code and validate the credibility or the logic behind the process, the whole process or program. But what we can test is sending the $10 coupon like 20 times. So it's gonna be $200. And we're gonna check. So how that happens. Here, let's say, for instance, we have this. I mean, I can draw that in draw.io, you know? But I love drawing for myself, even though that my draws sucks. Okay. So here we have each one of them is 10, 10, 10, 10. Each arrow representing then a $10 value. So we are trying to get all the process through all of these processes at one time, and thus we get the money. So how can we escape or evade this vulnerability? There are many ways there are many ways that we can do through here. And here the detection and mitigation, they are telling us either through synchronizing mechanism, which modern programming languages provide, and atomic operations, which refers to indivisible execution units, a set of instruction grouped together and executed without interruption. This approach guarantees that an operation can finish without being interrupted by another thread. And database transaction, so like to save logs in order, so a real employee would verify that. And what does that mean? That let's say we're gonna process the first one and check if we have then enough credits, or the code is not being activated yet, to activate the second, the third, whatsoever. Sometimes it's not about only the amount. Sometimes the thread is being interrupted by something else, or it's really complicated. So that's the story behind the race condition problem. So here we get back to our stuff, and here we have a program, I believe in Python as well. Yep. Once you see import, then it's in Python. So they are giving us the second example. A bank account has 75. So thread 1 checks the balance, which has 75, and withdraw 50. Before thread 1 updates the balance, the second thread works and get the other, I would say, withdraw other 50, I believe. Thus, we don't have enough money to withdraw this 50. So each arrow, you can imagine that as a thread. And here an example of threading. So here we are running Python. So thread 1's value was 10, thread 2's value was 11. Then instead of, like here we see 10, 11, 12, 13, 14, then 16, and then 15. So instead of thread 1 then being followed by thread 2, here we see a gap. Thread 1 overtook thread 2 and it repeated itself. So that's representing the race condition. They are racing between each other. So here they are telling us if we run the program second time, we would see different values because threads are not unique. Threads are unique. They are not identical each time you run this, even though the same process and the same code. And here they are telling us on the attack box you can try and run the code. Thus, I'm gonna skip causes, or we can check causes together. So the parallel execution, as I explained with arrows. Database operations, I didn't talk about that. It's referring of the because whether the program should I would say withdraw or activate the code, it needs to get back to the database and check if the code is really in the database or not, just being like generated by an AI or by a human, or there is no typo in the code. And third-party libraries and services, maybe your program is not vulnerable to race condition, but the services that you are using or the libraries might be. So here, does the represented Python script guarantee which thread will reach 100% first? As we've seen together, nay. In the second execution of Python, what is the name of the thread that reached 100? I believe thread 2 or 1. So 2. No, 1. Here is it. Okay. So the client-server model. Each web application has client-side and server-side, and they are explaining that typical web application has presentation tier, application tier, and data tier. We are not going through that. They are explaining in a deep matter how web application overall works, and the states of that we have. And here are the conditions that I represented them at the draw over here. Here, for instance, they are giving us an example. So first thing or first condition is gonna be user clicks or first event, whatever you're gonna call it. User clicks, confirm transfer. Then the application queries the database. Then the database responds to query. Then is the amount within limits? If yes, then conduct the transaction or the withdraw or apply the coupon code. If not, display an error message. So all the race condition happens in this area where the thread doesn't have time to, I would say, to reply or to give an answer to all the threads or all the processes. Thus, you have race condition. So here the amount not set, as I've said at the beginning, it's not a binary decision, sent not sent, and the full amount or the full money would be deducted. No, it's not that easy. Always we have a little bit of logic behind our program in the back end. And here they are telling us about the two states. So we add in coupon, checking coupon applicability. If it's not applicable, then get back to the first state. If it is, then apply the coupon. However, that's representing a case which has a high intensity of race condition variability. It should be like somehow like that, like this image, which has a little bit of more complication and has enough time to react to so many threads or so many coupons being activated at the same time. And I really like this image because it really represents the idea or the notion behind race condition. So here we are adding coupons, and we are checking here where the variability either happens or not. Either after recalculating, does the coupon value still has been activated or can be activated 2 times or 3 times or whatever times, for instance, like the Discord invitation, or no, and then get back to the first state. So here they are explain. You can read that on your own if you want more information. I really recommend this room for the race condition. And how many states does the original state of diagram? Validation and conducting money transfer. Let's check the first diagram. So 3, 4, 6, I would say. I'm not mistaken. Okay, it's not correct. Maybe 5. Okay, let's check that. So 3 states. Okay. The application shows an error message. So probably they are talking about the basic logic, which is either conducted or not, about the amount sent and not sent, not the final notion or the final idea, if I'm not, yeah. And how many states did the updated state of validate and conducting money transfer have? Maybe the 6? No, let me check again. The final one. Okay. So let's get back to these, not the final form. So here we see we have amount sent, amount not sent. Okay. And here I believe they are talking about the verification before sending the amount. Here they are talking about the coupon, it's another one. So here, I believe, yeah, they are talking about this. Amount not sent, then checking balance and account limits, then sending the amount. So maybe 3, not 6. And validating coupon codes and applying discounts. So here is the first one, the second one, third one, fourth one, fifth one. So I believe here 5. Yeah, that's correct. And here we activated our machine. It's up by now. Let's visit this. So I have, let me pause a little bit to close the HackTheBox. Okay, now I'm gonna move this to my first desktop and let me sign in. Okay, I cannot log in. Okay, somehow I cannot remove or I cannot use backspace. Okay, so here we are. I'm gonna connect to Tryhackme. If you are new or if this is your first time watching my channel, I usually connect through just typing Tryhackme. You can either make your own auto code, auto connection, or use the pseudo VPN. Or if you are still, oops, no, let me switch over here. Okay. Or if you are still new, you can use the attack box if you don't know how to install and make your own Kali, your own and write your own Kali and add the programs or install Burp. I believe Burp comes with Kali by default. So let's get back to our work. I'm gonna move to here and fire the Firefox. I'm gonna launch Firefox and gonna connect to this. So here we have a proxy error because I have Foxy Proxy proxying all the data to Burp, but Burp is offline. That's why it's not working. So here we have username, password. First thing I have in mind whenever I see this is checking SQL injection. Okay, SQL injection over here as well. We need to check through Burp if it's variable or not. However, that's not our case. Here they are telling us we have two users. So whenever you need to make two users or more, you can either make a new private window and copy the IP, or I prefer to use, if I can remember, Firefox multi-account containers. So I would launch a second container. It's not a real container like Docker, but you have isolated environments. So I'm gonna use user one over here. Oops, I took a screenshot by mistake. And I'm gonna sign in over here. Then I'm gonna move here and sign in with the second user. And here we have, so before checking what Tryhackme is trying to teach us, let's check the functionality of the program. I'm gonna fire up Burp Suite. And now I'm gonna send all the data through the proxy to Burp. Okay, now let me get that big. Go into proxy. I'm not intercepting it yet. And here we have pay and recharge. So we need to provide the mobile number and confirm that and the amount. So here we have 7.5 and here we have 6. Let's send the, maybe there is gonna be charge value. So I'm gonna send 7. And let me take the, I believe the second user, mobile number. And I'm gonna send that. So transaction successful. I'm gonna refresh over here. Here we have $13. Oops. Let me get back to here. Okay. Now we're gonna test the business logic. I'm gonna try with, okay, I cannot type minus value. Maybe I'm gonna say 0.001. I cannot type that as well. Let's try 0, 1. So if we had, so I believe the business logic, yeah, works perfectly over here, and we cannot type minus values. Okay, let's get back, because now we are interested in the race condition. And here I'm gonna say pay and recharge, and over here I'm gonna provide the first user, and you can either provide the full value that you have, or less or more. So either, let's say you have now currently 13, 22. Okay, excuse my handwriting. So you can either send the 13, 22, or you can send, for instance, 5, or you can, of course, send more. So by sending more money, the first request is not gonna be successful. So thus, all the requests follow up are not gonna be successful. Thus, the thread won't be overloaded because it's processing thread by the first state or the first step, and it's not being overloaded. By sending the whole money by the first time, sometimes might work, sometimes might not. So I prefer not to send the whole money the first time. I would preferably say send less than the money, so at least thus the first 2 or 3 transactions or processes or whatever you're gonna call them are gonna be 100% successful, so they're not gonna fail. So by sending 5, at least it's gonna work twice. Then third time we're not gonna have enough value to do 13. So I believe by 4 is enough. So I'm gonna send 4 20 times. So I'm gonna send almost $80. Let me check Tryhackme. What do they need from us? Let me check over here. So more than $100. So I'm gonna send $4 30 times. Let me get back to here. And I'm gonna say $4. And we are intercepting. And Control R to send that to repeater. So here is our request. Our request is a post request sending the data from the dashboard transfer, and here are the post parameters, the mobile phone, the confirmation of the telephone number, and the amount without the $sign, of course. We have cookie session. Okay, that's great. Let's get back to the race condition. So by clicking send, we are sending our request once. Clicking send twice, sending, of course, twice, 2 times. So we need, as I've mentioned, to send that 30 times. How to do that? So we need to make a group in Burp. It's called group. I'm gonna call that race 1. And inside race 1, let me get that. Okay. Now, so inside here, okay, why I cannot edit that? Yeah, inside here we have duplicate tab, and within duplicate tab, I'm gonna say 30 times. Please duplicate that 30 times. So by clicking on each one of them, I'm sending one request, one different request. However, I need to send all of them, not each one of them alone. So we have separate different settings, 3 different choices. Send a group in sequences, in a sequence, or in sequences by single connection, and by separate connections. So you can send the 30 requests by a single connection, by a single handshake, which is represented here in the Wireshark. You can check that on your own, or by separate connections. However, we need to send them in parallel in order to exploit the race condition vulnerability. So let me try that. So we are sending 30 requests, and let me get back to here, refresh, and here hopefully we're gonna have $100 or more, yeah. And here is our flag. Let me get back to here, paste the flag, detection and mitigation as I've mentioned, and the challenge web app. So let's go to this IP. Okay. Let me turn off Burp a bit. Let me pause. So I tried to refresh. Probably it's down by the overwhelming requests that we had. Let me terminate that and start the machine again. So while we are waiting for the machine to start up, please guys, make sure to subscribe. Okay, so while we are waiting for the machine to start up, please guys, make sure to subscribe. Most of you, those who are watching my videos, are not subscribed. And let's get back to our machine. So it's not up yet, and here is it. Get back and paste the IP. So we need the 5000 port, and let me close that. Have my personal. I'm gonna have my work, and here is the first user with the password, and the second one, white horse. Okay, let me copy that here. I mean, that's so dumb. No, that was wrong. Let me just copy paste the pass. Okay, I'm gonna save that, and then the username. Gonna take this, paste that here without the dashboard, take this username with this password, and save that for me, please. Okay, so here we have 3 users that can send to each other. Let me try and send all the money to the first user, which is Rasarkond. So I'm gonna send the 100. Okay, here we have charges, and let me intercept that. Processing. Okay, I've missed that. No, don't intercept that. Let me try this again. And intercept this time. So here we see the request. Okay, nothing is interesting. Here we have the fund, the fee, and the amount is gonna be received. So if you want to test the logic, however, that's not the case with this program, with this web app, you can try to change this more than the values over here, or to change these values in according to this, but more than the value that you have. You can try and play with those. However, I'm gonna just forward the money. Okay, what a scam. So both of the account have by now 0. Yep, and here should have at least 2080, 2090. However, that's not the case. Let me exit. So the web app is not that stable. And I'm gonna sign in again with the blue apple. Save that. So yeah, we have 2090. Let me send it to the second user. So I'm gonna intercept. I'm not gonna intercept this. I need to intercept here. So we have 2090. I'm gonna send, I would say, $80, and we need 1000. So at least we need to 15 times to repeat that. We have charges. Okay, I'm gonna send that 20 times, and I'm gonna send continue. Let me delete those. So here you can close all tabs and send this to repeater. Control R. Make a group. It's gonna be task 2, for instance. Then duplicate tab for 20 times and send them in parallel. So probably it worked. Let me shut off the interception. Okay. Do we still have our money? Let me sign out. So first user 4621, yes. Here we still have our money. Do we have our money over here? Let me check. 6282. Nah, we don't. Okay, let me do that again. So the web application is not that stable, as you see. So I'm gonna send 80 and intercept that. Close those. Send it to repeater. Let's try for fun this time 30 requests. And send in parallel. So here we see most of them worked finally. I'm gonna forward that, the genuine request. Let's try and turn off the interception. So we're still having the same issue. Alright. Okay, maybe it's being overloaded. I'm gonna try that again. This time I'm gonna send, let's say 100. Let me send 200. How much do we have? Let me send 200. And we're gonna send that 4 or 5 times. I'm gonna send that 6 times. Let me intercept. Send that to repeat after closing this or before closing these. Alright, so I'm gonna just make a group, duplicate 6 times, let's say 7, and send those in parallel. Let me forward this as well. And turn off interception. So hopefully by now. So the issue, I believe it's because the web application is not that stable. Okay, still didn't work, and our process has not worked. Yeah. Let me try that again. Gonna send 250. Let me close this. Let me duplicate that 5 times. Let me send this with those. Still probably nothing happened. Maybe I need to turn off the interception. Send that to repeater. Duplicate that. And check the second one. Bruh, I'm gonna try that and unpause when I'm finished. Okay, so I restarted the machine. Probably it fell off because of the many requests. So I'm gonna try to. Let's try this time with the second account. And from the second account, we're gonna send everything to the third one. Okay, so here we see the first has been processing for a long time without interception. Okay, so here we are. I just waited a little bit because the program is poorly optimized. So we need to make this 1000. So we need at least to send this 5 times. So let me go to here, type 200, or how do 195. Let me intercept that, press continue, and let me close this again. I'm gonna send that to repeater, and make a new group, duplicate that, oops, 5 times, send them in parallel, and drop our request. Let me sign out. With the blue apple. So we see that went only one time. Let me go out and sign in with this user. So here we have both of them 0 by 0. So only it went once. Let me intercept that again. I'm gonna send to the third one again. Gonna close this. Send it to repeater. Okay, by now I'm gonna increase a little bit the duplicate number to maybe 7. Okay, I'm intercepting the wrong thing. Not yet, not yet. Close other tabs in group with you. Let me check how much do we have again. So we have 285. I'm gonna send that to the third one. Intercept that, continue, and send that to repeater. Over here, make that 7 times. Oops. Send them in parallel. And let's drop this. Let me sign out. Sign in again. Still no money. So probably we have an issue by sending money to the first user, by the first user. So he doesn't send money to the others. Or now because I'm sending and I don't have charge. Okay, now I understand. Whew. So let's try 270. Okay. Let me intercept that. Go to repeater. Close this group. Make a new one. Duplicate. So because we don't have anything to show us what the issue is, I couldn't know if maybe the issue with the user or the credit. Let me sign out, sign in again. Hopefully by now we have the money. If not, it's gonna be crazy. So yeah, probably the first user has something with sending the money. Let me try again. So the issue is from the web application, but I hope you got the idea. I'm gonna pause and get back to you once I finish with this program. Okay guys, so the web app is under optimized and I couldn't get that, although I've done that before the recording, but somehow the servers, or maybe I've missed something, I'm not sure. So I'm referring you to this race condition on Tryhackme by Notvo. Let me clap for him. And what we need to understand, which is more important than the flag, is whenever we send a request, the response would be result equal true, but our request was redirection. So once you get the result equal true, then the money has been withdrawn from your account and transferred to the other account. So that was it, and thank you guys for watching, and hopefully everything would be great and you won't have the same experience that I had with this challenge. And see you next time.